to talk about the on-demand defrost operation. It'll be for the 16 SEER mainly. Some of the screenshots I have is for 16 SEER, but the algorithms are the same for the 16 and the 20 SEER. But I've talked a lot about the 20 SEER before, but not too much on the 16 two-stage LS. So I wanted to kind of turn the focus and attention on that today and go through it and then give you hopefully some things you didn't know about here. So what we're going to talk about today, the heat pump, it measures differential temperatures to detect the system is performing, if the system is performing poorly because ice buildup on the outdoor coil. So obviously that's what defrost does. So that's that. The controller self-calibrates when the defrost system starts and after each system defrost cycle. So I'm going to say that again. The controller self-calibrates when the defrost system starts and after each system defrost cycle. That's going to be a key point here in just a few minutes whenever I start talking about some other things that I'm going to talk about. The heat pump control monitors ambient temperature, outdoor coil temperature, and total run time to determine when a defrost cycle is required. And these things have a lot more meat to them in just a few moments. The coil temperature sensor is designed with the spring clip, and it's going to be hooked to the outdoor coil tubing. What's not written here, it's imperative that you, if you have to replace them or anything of that nature, put them back where they belong. Okay, usually on the 2 and the 3 tons, they are 12 rows up. And on the 4 and 5 ton, they're going to be about 24 rows up. If you start moving those sensors in any way, shape, or form, it can throw the whole thing off, and you'll see why in just a few minutes. And that's why the location is really important for this. So this is kind of our 50,000 foot view of what I'm going to talk about. So as we go into it, defrost calibration. So we talked about that in just a second. Heat pump control monitors mode of operation through outdoor ambient temperature, outdoor coil temperature, and compressor run time to determine when a defrost cycle is needed. And over here is a little bit of the range. I got a little bit better range coming up in just a minute. But I wanted to lay this out. If I had a real picture, it'd be better, but this is some of the drawings. But this is your coil sensor, and this is your outdoor ambient temperature, and this is your discharge line sensor. The discharge line sensor can throw a code, but it doesn't have anything to do with the defrost and how it's going to do. I snipped this out, the ambient and liquid line sensor temperatures. I snipped this out to show 35 degrees down to 25 degrees. And if you look at the ohms rating here, so 10K ohm resistor, but it's a 10,000 ohm difference just between 10 degrees. So when we're out there looking at these and when we're talking to contractors working on these things, it is highly important for them to understand that we need to be somewhat within this range. But I also found what happens if these sensors mess up, what algorithms is in the board if these sensors mess up. And I found it to be very interesting when I found it, and I want to share that with you today as well too. So defrost calibration. The coil sensor detects temperatures below 32 degrees, 2 degrees Celsius, during either an initial power up or after a loss of power or after cooling mode. A sacrificial defrost will be used to ensure that there is a clear coil before attempting calibration. Let me kind of walk us through that. If you cut the power off and back on, it's going to have to recalibrate itself, the initial calibration, okay? If you lose power, same thing. If you have yours set like mine, and I kind of mentioned the weather for a reason, this morning my heat was on, this afternoon my AC will come on. Well, back tonight when it goes back in, because it went in the cooling mode, it will have to calibrate again. But this is not the only time it is calibrating. Through the research that I've done, this board is a lot like an A97. It kind of forward thinks and backward thinks. It forward learns and backwards learns. And I'm going to show you that in just a moment as well. So let's look at exactly what needs to happen during a calibration cycle. So the coil sensor's got to be below 35 degrees. A cumulative compressor runtime with the outdoor coil temperature sensor below that 35 degrees. And then we're going to need 30 to 35 minutes of compressor runtime. And then it's going to initiate a defrost and monitor the coil temperature sensor and input and a cumulative time. All this I can continue to explain as we go, but just to make sure. So this is part A of that. Now, when we calibrate this, some of the factors that it's going to weigh in is how did defrost terminate? What had to happen for this board and the sensor to say the coil's clear? Well, that's always been a question that I get, and that's why I did it this way today. So the coil temperature sensor reaches specified defrost termination temperature as set on the heat pump control pins. I'm going to show you those control pins, but I'm also going to show you the A3, and I'll get into that, but it has to reach that temperature. Defrost for 14 minutes without the coil temperature sensor input reaching defrost termination temperature as set on the heat pump control pins. Now, if we're in a very cold climate and it's a cold day when they put this in and it has to run 14 minutes, it's going to calibrate to that. And a lot of folks get worried, okay, what's going to happen when it warms up? It calibrated when it was real cold, and when it warms up, what's it going to do? That's what I want to talk to you about. That's what I want to really get clear in everybody's head today on this. So after the initial calibration, the heat pump control disables the defrost for 30 to 34 minutes. I have no clue why it's 34 minutes. That's what it said in the documents. So, but it's going to avoid unnecessary defrost. So what this is saying, after we're calibrated, I'm not going to let you go into a defrost regardless if the conditions are right for at least 30, 35 minutes. Beyond this timing period, both the ambient and coil sensors are continuously monitored. That's what I told you about the forward learning, backwards learning, forward thinking, backward thinking. So if the coil temperature is below 35 degrees in calibration delta, and you'll see I got delta written in here in red because this is going to be a topic for us to talk about, is reached or accumulated compressor runtime of more than 6 hours of more than 6 hours. So if it's run 6 hours and it hasn't gone into a defrost, then it will. No matter what the sensors are saying, it's going to go into a defrost, and just check it. So delta is what I really want to start talking about and making sure we understand exactly what that is. And I tried to take a picture with my phone today and try to get it to him, but I didn't because I looked at mine today to look at it, but I do have some things here to show you. So when we do this, and I don't know if everybody knows this or not, but right now we're going to go to the dealer control center and then we're going to go to diagnostics because we want to see all this stuff and how it runs and how it's going to work. Okay, but we got to be able to see that. So once we get to the dealer control center and we click on the diagnostics, this screen is going to come up. You're going to check just the heat pump for now. You can do both if you want while you're at the job site, but for our purposes today, I want to just check the heat pump and make sure. So I'm going to check the heat pump, and down here at the bottom, it's going to have run start test. So when I hit start test, this comes up. Now, I just got an email a little while ago about some updates that have been pushed out. This may be a little bit rearranged, maybe a little bit different on your stat, but the control with defrost at delta, current delta, and run time since last defrost, that'll all still be there. Okay. I looked at my stat just a little while ago and it's all still there, but I want to talk about this a little bit. Troubleshooting purpose wise, it's a handy thing to understand and know when we defrosted last. How long ago was it? Because we talked about charging and all this other stuff and airflow and all this stuff, how we build up to this. Once we get all that correct, then we'll know if it's a control problem or airflow or anything else. At this point, we're going to, I'm not going to say assume, we're going to guarantee we've checked all this other stuff and got it right. So I can look at this and say, okay, it's been 90 minutes since I've run, or 2 hours. It's been 2 hours since I had a defrost last. But the two I want you to really look at is the current delta, and the control will defrost at delta. And I'm going to take a look at this picture so I can describe for you what is on my stat. So my control will defrost at delta is 0.6 Fahrenheit. Okay. This is when it warmed up. In the morning, it was a little different. And I'll talk to you about that as well. But in the morning, it was a little different. And the current delta was 3.4 degrees. That's between the two sensors. My unit was off when this was happening. So what happens is, every time this thing goes into defrost, it's going to look at these temperature deltas. It's also going to look at how long it stayed in the defrost. If it took 14 minutes to get to a defrost, what this board and what the unit and all is going to do, it's going to narrow that gap of the controlled delta. So it might be, 0.6 this time because it's warm outside. Next time, it might be 2.5 degrees. It might be asking for a quicker defrost. It's always going to take into consideration every time. It's going to do a self-internal, and I hate to call it calibration, but that's what it is, a self-internal calibration. Because again, I go back to what I said, if we ran this thing on a cold day or started it up on a cold day, well, then it's going to be much different than a mild day. That is that first initial sacrificial defrost that they do. That is just to get a nice baseline started. Once it gets the baseline started, it'll always sit there and do this. But you can go to the stat, look at this, and especially while you're on the call, and see exactly when and it'll tell you in real time that delta. It'll start reading it and it'll start narrowing down, and by the time it gets right there, boom, you got it. Now the Wi-Fi version, or the white stat, it does the same thing as well. You can see the deltas on there. It doesn't give it to you quite as quick as what this does, because it has the smart hub and it can process the information a lot quicker. But I would encourage everyone who gets on the phone with someone working on this and they believe they're having some defrost issues, I would start looking at this, seeing what their delta is, and ask them, did you cut it off at any point in time? Have they lost power? Because if they have, then that 30-minute runtime initially, it's going to bring it on anyway. You're not going to get a good feel for exactly what's happening. This will let you know. This is some really good information to know. And you can't get it on a 16 series. We can use a standard 2-stage stat, but you can't get that information off of that. So that's one of the things that the A3 brings to the table for us. Not trying to be a salesman here, just saying, for those of us who like to troubleshoot and know every single point of what we need to know, this is the ticket right here. So how do the sensors act when there's an issue or a problem? So if the ambient sensor is detected as being open, shorted out, or out of the temperature range of the sensor, the heat pump control will not perform demand defrost operation. It will, however, revert to time and temperature defrost operation. So it'll still work, even though the ambient sensor's out. And then your heating and cooling, it'll give you a code, an alert code here, but it will allow your heating and cooling to still go on and work. So it'll give you a code saying, look, we got a problem with the ambient sensor. That's a good thing to know. And the reason I put this on here is if they get the codes on their phones and all that good stuff, and the homeowner calls and they look at it and they go, outdoor ambient sensor, well, if they know it's still going to work, they might bump that call to the last part of the day, knowing all I got to do is put on a set of sensors and go on about my business and take care of the ones who really don't have any heat and that type of thing. So that's what's going to happen. That's how this system is going to react if the ambient temperature sensor goes out. If the coil temperature sensor goes out, okay, if the defrost coil sensor is open, shorted, out of the temperature range, the heat pump control will not perform demand or time and temp. It won't perform either one of them on defrost operation. It will display the appropriate fault code though. Heating and cooling will be allowed in this fault condition. So you're going to build up ice on this thing pretty bad. So it's important for this code, if the coil temperature sensor's out, it's really important that, okay, now we've got to take this call first because we don't want ice to build up, get stuck on the fan, burn a fan motor up, or anything of that nature. So the difference between the two and when it goes out is pretty critical to the thinking and the mindset of the person going out there working on this. And as I said, the discharge line temperature sensor, it's kind of a nice backup to the high pressure switch. So if that line gets too hot, for some reason or another, if the high pressure switch is messed up, then it'll take it out, but it's not going to affect any way the defrost is going to work. So if anybody says, does that, have effect? No, it does not. All right, so the control boards for the systems with non-communicating stats, it'll operate jumpers located on the board. I'm going to go over the jumpers in just a few moments, okay? For the A3 communication, we're going to do it on the thermostat, okay? And I've got some screenshots coming up here to show you why it's important to look at this. So just remember, if they do decide, if the contractor does decide not to use an A3, they can do that. That is definitely their preference, but they're losing a lot of troubleshooting ability when they do that. So let's talk about the A3 and when we're doing our setup, because I made this mistake until I went back and looked at it while I was doing this, went, oh man, I've clean forgot. I was supposed to go back in and look. So I went in to equipment, my smart hub. Again, I'm not going to go through how to get to this. We've already gone through the A3 and done that. So there's a couple of things here I want to talk about. Lock-in second stage heat pump by outdoor temperature and electric heat stages during defrost. Now, on the board, I'm going to show you how to do it, but here I'm going to show you how to do it on this stat. And again, if you see a 20 SEER, this particular thing will not show up. Whenever it reaches out and communicates to it, it's not going to show this, okay? So again, I'm focusing just on the 16 SEER today, but everything I just spoke about is the same algorithms that a 20 SEER is going to use as well. So you can almost plug and play this other than a few screenshots. So when I go here and I look at this, so I'm in the smart hub, I'm not in the heat pump yet, we'll get there in a minute. These are two of the main things I want to look for. The second stage lockout, and this is what it's going to give me. You can go 40, 45, 50, 55. That's pretty important to the customers, their comfort, but depending upon when you lock that second stage in, that can also affect how many times it'll go into defrost as well too. If it's running at lower stage, it's going to run a long time, and our cumulative runtime will build up in that case. But if we don't run and we go full stage, 100% capacity, we might not run as much. So there's a fine balance in there that you're going to have to look at for your particular region and where you're at. If you're the panhandle of Florida, it's going to be much different than if you're in the Tennessee Valley. Completely different set of circumstances, completely different set of settings right here. But this is where it is on the equipment, on the A3 comfort sink. And then you go to your heat pump right here. Your defrost termination temp, you can go from 50 to 100. The default is 50. So again, pay close attention, because when I put this A3 on my house, it did not pick up what I had previously set before. It stayed at the default. So we need to make sure they look at this and adjust it, because they can go 50, 60, 70, 80, 100. Make sure what region you're in, this gets adjusted, because that could be a callback where we're spending a lot of time trying to figure out what in the world be causing this, and here it is right here. So another important thing to take a look at as we put these in. So that's the easy way to do it with the A3 comfort sink. Those are some of the easy ways. Now, I mentioned that if they use a conventional stat, they're going to have to make all these adjustments on the board. So I just want to point out a few things on the board here. You still have the compressor shift delay. Not a big deal. Everybody's going to leave that on there. Here's your second stage lock-in temperature, two-stage heat pump only. You got 55, 50, 45, 40. So that's Again, if you set it here, your target's only going to be 55 degrees if you use it on the board. Keep that in mind too. You noticed on the A3, you had 100 degrees. Here, no, excuse me, this is the stage lock-in. So it's 55 degrees. So it's the same as the stat. So make sure if they want to lock this in, make sure they do it right here. But they've got to do it on the board. And you can do it when the power's running and it'll take it, but my suggestion is not to do that. My suggestion would be before I crank this thing up and before I do a startup on it, I'm gonna go ahead and take a look at this board. If I know I want to adjust it because I've already put heat pumps in this particular region, then I'm gonna go ahead and adjust it, and that way it's out of sight, out of mind. You know it's done. But here's the defrost termination temperature. I just got messed up. You got the 100 degrees. Default is 50, just like it is on the A3 stat. So that makes a difference as well. So this is what I wanted to really emphasize today, is to go over this, and I wanted to just hyper focus on this, because with that, I'm going to stop it for today and let everybody kind of soak that in. Caroline, if you can go ahead and stop recording, please.